Hello everyone, my name is Abhiram and today I will be going over the following problem subsets. So given an array of unique elements, we have to return a subset, we have to return all possible and distinct subsets. So for example, right here, we have an array with the values 1, 2 and 3, and based on this array, we're going to return all the possible distinct subsets, which includes all these values, including an empty list and also a subset with all the values in it, and also and many other values. So in order to do this problem, there's several ways, but we're using a recursion method where we break down the problem into smaller pieces, then we bring it back together. So as you can see in this flowchart, we start with like two so if, let's assume that we have an empty list and we have like two possible values. We can either start with like an empty array, or we can start with the value 1. After value 1, we can add we can choose to include 2, or we can choose to include 2, or we can not include 2 as well. Then after that, we can include the value 3, or we can include the value 3 as well. By using this flowchart, and recursion, we're gonna get all the distinct subsets from this array. So now let's write this algorithm. So def nums. So let's just find the length of the array. So n equals to length of the array, and after that, so let's just create an empty list. This rest list will hold all the values, and after that, let me just create another empty array to hold the sub values. Now here comes a recursion and the recursion part. So here def backtracking. So and I here is just a pointer, and this is what we're going to do. If the increment is like greater than the length of the array, I is greater than or equal to n, then we can add this like subset to the list. So res dot append. Now look what I'm doing right here. Instead of writing the subset, one of the problems will just like passing an array or like a list as a parameter is that, like, since an array doesn't, we can also make a risk of not just passing the values but also passing the references as well. We don't want to pass the references, we just want to pass the values. So I'm gonna just like copy the values and create a shallow copy, so that way the references are not like passed. And after that, we can just return. Now here's the part. So now we can choose a increment. So first let's just append the value to the array. So subset dot append nums I. Okay, and after that, after appending it, we can now we can call the backtracking algorithm again. Backtrack I plus 1. Now since we're done using this element, so we can stop using it. So now we can subset dot pop, and then again we can call backtrack once again, offer of I plus 1, and now we can just return the result. And prior to that, we'll just call the backtrack function with the value 0, and this is pretty much the solution for finding all the distinct values of a subset. So now we just within this algorithm, we just created an inner function that can help us with the backtracking, and we pass the value 0. And now if it's like greater than 0, then if the value is greater than the length of the array, then we'll just append we can append the shallow copy of the subset to the main result. Then after that, we can append and then prior to that, we can just append each value. Then we can backtrack again, and then once we reach the final spot, we can just like append it, and so on. Thank you very much.